Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to this physics session of daily 10 MCQs. So today we are going to discuss rain umbrella and river boat type of questions, that is motion along plane, and it is a relative motion in a plane. So welcome to Bohdi Park NEET and J Academy. You can access various study materials. For that you have to download the app. The link for the app is mentioned in the description. So let's start with first question. Look at this first question. A swimmer can swim in still water at a speed of 5 meters per second. Takes T1 and T2 time to cross a river in shortest time and shortest path respectively. What do you mean by this? Suppose this is the river. River is flowing eastward. The direction of river is west to east, or we can say right. The swimmer can swim in still water, so we call it velocity of swimmer with respect to river. Like in case of boat with respect to river. So here swimmer with respect to river. So muscles energy or muscular energy is needed for this. In still water, how person can swim? The self energy, muscles energy, muscular energy is required. Okay, so muscular energy is supplying this speed. Okay, so this is given as 5. Takes T1 time to cross a river in shortest time and shortest path. So suppose how to cross the river in shortest time. So you see, suppose this is the direction of boat or the swimmer. So in this direction the swimmer will swim, or the engine of the boat will supply velocity in this direction. So we can call it velocity of swimmer with respect to river, or boat with respect to river. And this direction is known as upstream. This is downstream. Down. This is downstream. This is upstream. So with upstream it is making angle alpha. So if you take the components, it will be VSR sine alpha perpendicular to river, and VSR cos alpha along the upstream, and the river velocity is along downstream. River will take the boat or the swimmer downstream. So you see, the time to cross is equal to width of river, W is the width of river, divided by VSR sin theta, VSR sin alpha. Okay, so this is the still water speed of boat or swimmer. So we know that if time is shortest, for shortest time sin alpha should be a maximum, so that is 1, so alpha is 90 degree. So basically the boat should point perpendicular to river, so alpha should be 90 degree. So the time to cross is this. So minimum time or shortest time will be equal to, put this 1, so W by VSR. Now this is given as T1. T1 and T2 are time to cross the river in shortest time and shortest path. So shortest time is given as T1. Okay, let's make it first equation. So this is the direct formula also. Now to cross the river in shortest path, the boat should point such that it will go perpendicular to river. So these two velocities should be equal. So for shortest path, VSR cos alpha is equal to VR. VSR cos alpha is equal to VR. So cos alpha is equal to VR by VSR. So we have sin alpha is equal to square root of 1 minus VR square by VR square. This is sin alpha. So we will put this value of sin alpha here. Then we will get time to cross in minimum distance. So that is given as T2. So T2 will be equal to W by VSR square root 1 minus VR square by VSR square. If you solve this, you will get W by square root of VSR square minus VR square. So this is T2 and this is T1. Now you see here in T1 we have a VSR in the denominator, and in T2 we have square root of VSR square minus VR square. So clearly here denominator is less. So less denominator, so whole number will be more. So we have T2 greater than T1. T2 greater than T1. So we have the option. Okay, we have to compare T1 and T1 dash. Okay, so now in the second case, the speed of river increases. So you see this minimum time does not depend on speed of river. Okay, so it will be equal. So T1 is equal to T1 dash, because you see VR is not there in the formula. Okay, so no change in T1. So T1 is equal to T1 dash, but for T2 VR is there in the denominator. So the speed of river increases, so VR increases, so denominator decreases, so T2 increases. Okay, so T2 dash will be greater than T2. T2 dash is greater than T2. So we have third option. Okay, done. Now next question. Now look at this question number 2. A swimmer swims a distance d upstream in 4 seconds and swims equal distance downstream in 2 seconds. What is the ratio of speed of swimmer in still water and to that of speed of river water? Okay, so that we have to find the ratio. So let's draw the river again. So suppose this is the river is flowing towards east direction. So swimmer swims a distance d upstream in 4 seconds. So suppose this is the boat. So this will be VBR. So we can say boat with respect to river or swimmer with respect to river, anything. So river speed is VR, right side, and upstream direction is against the river flow. Okay, this is the upstream direction and this is the river flow. Opposite to river flow is known as upstream and along the river flow is known as downstream. Okay, so we are talking about upstream. So VBR, resultant velocity, VBR minus VR, this is the net velocity, is equal to distance is d by time taken. So time taken is 4 seconds. So this is first equation. Now in the second case, which is downstream, the river is pointing along the river flow. So this is VBR and this is also VR, direction is same. So resultant velocity is VR plus VBR. So that is same distance, okay, equal distance in time 2. Okay, speed is equal to distance by time. So d by 2. So this is second equation. Okay, right now, like this is the second equation. So ratio of the swimmer's speed in still water to that of speed of river. So we have to find VBR by VR. So now we can do that using divide. If you divide these two, we get VBR minus VR divided by VR plus VBR is equal to d by 4 by d by 2. So that is equal to 1 by 2. Now cross multiply. So 2 VBR minus 2 VR is equal to VR plus VBR. So now solve this. So this is VBR is equal to 3 VR. So that is equal to VBR by VR is equal to 3 by 1. Okay. So that is second option. Okay. So done. Now next question. Now look at question number 3. Rain is pouring vertically downward at velocity 4 kilometer per hour, and magnitude of velocity of rain with respect to man running along north on horizontal road at 3 kilometer per hour. So let's take we have this board, so let's represent north south direction. Okay, so suppose this is north direction, this is north direction, and this is south direction. And this is vertical direction, so vertically downward. So rain is falling downward, vertically downward, vertically downward. So velocity of rain will be minus j. Okay, minus j. This is minus j, and this is I cap, and this is minus I, this is j cap. Okay, clear? So rain is pouring vertically downward at 4 kilometer per hour. So this is minus 4j. Okay, VR vector, and now we have to find magnitude of velocity of rain with respect to man. So velocity of rain with respect to man. So in vector form, it will be equal to VR vector minus Vm vector. Okay, this is relative velocity formula. Okay, this is relative velocity of rain with respect to man. Okay, so VR vector is minus 4j minus Vm vector. Now what is Vm? It is along north. Okay, man is going along north with 3 kilometer per hour. So velocity of man is 3 I cap. So magnitude will be square root of Vrm vector. Magnitude will be square root of 4 square plus 3 square. That will be equal to 5. So done. So 5 kilometer per hour, second option. Now next question. Now look at fourth question. A girl standing on a road holds her umbrella at 45 degree with vertical to keep the rain away. If she start running without umbrella with speed 15√2 kilometer per hour, the raindrops hit her head vertically. The speed of rain drops with respect to the moving girl. In the second case, okay, there are two cases in this question. In the first case, the girl is standing, and in the second case, the girl is moving. Okay, so two cases are there. So let's draw two cases. So case 1, the raindrops are coming at 45 degree with vertical. Okay, when the girl is standing. So suppose this is the direction of raindrop. So this is velocity of rain. So umbrella will be like this. Okay, and the person is holding it like this. Clear? Opposite to rain. Now this angle is given 45. So this angle is also 45. So we can say the x component of the rain is x and y component is y magnitudes. So velocity of rain is equal to minus x I cap minus y j cap. Clear? So this is the case 1. So that's it. Now if she start running without umbrella with 15√2, raindrops hit her head vertically. So the question is, in which direction the girl should run, right or left? Okay, or you can say east or west, which direction? Or you can say I cap or minus I cap, in which direction it should run. So you observe that, suppose we don't know which direction, so you can assume, let girl run east with you can say VR, V velocity of person, VP vector person. Okay, girl is a person, so this is the velocity of person. So what is relative velocity now? So VP vector minus VR vector. Okay, this is VPR, velocity of person with respect to rain. Velocity of person with respect to rain. So let's find out what is VPR, VP minus VR. So this is equal to VP vector minus VR vector, which is minus x I cap minus y j cap. Okay, and suppose let us assume VP vector is equal to say z I cap. Okay, so we'll put it here. So z I plus x I plus y j. Okay, so this is x plus z I plus y j. So this is the velocity of person with respect to rain. Now the raindrops hit her head vertically. So this is the relative velocity. The direction of relative velocity is vertical. When the running girl sees the raindrops are hitting vertically. So it means x component is 0. Okay, so this should be 0. So x plus z is equal to 0. So z is equal to minus x. And this is given actually. The x component of the velocity of girl is given 15√2. So z, the magnitude of z is 15√2. But z is negative. Z is negative because we already assumed x is positive magnitudes and velocity of rain is minus x. Okay, I cap minus y j cap. So z is negative. So that means the girl is actually going west. The girl is actually going west and z is negative. So this is equal to, z is equal to minus 15√2 kilometer per hour. Okay. The speed of raindrops with respect to moving girl. So that will be equal to yj, the speed of raindrop with respect to moving girl. So that is velocity of rain with respect to person. We have to find velocity of rain with respect to person is equal to VR minus VP. So this is a VP minus VR. So VR minus VP we have to find. So anyway, we have to find magnitude. So magnitude will be same only. So magnitude of VRP is same as magnitude of VPR. So this is the magnitude. Okay, this is 0. So this is the magnitude y. So answer is y. Now how to find y? You see one more concept here. This is 45 degree. This information we have to use. This is a 45 degree. this is 45. So x is equal to y. X is equal to y, and we got x is equal to 15 root 2. So y is equal to 15 root 2. So that is 30 by root 2. 30 by root 2 is 15 into 2 by root 2. So this is 15 root 2. Okay, clear? So third option. So you can remember this as a trick, short trick. The horizontal component of rain is x, left side. So if person is running left or west, so person will observe vertical rain. Okay, so directly in exam we can use this. To observe vertical rain, to observe vertical rain, person should run along horizontal component of rain. Horizontal component of rain. Clear? Remember this horizontal component is x, left side. So if person is running left side, the person will observe a vertical rain. Clear? Okay, done. So next question now. Now question number 5. A man is walking on a horizontal road with speed 4 km/h. Suddenly, rain starts vertically downward with speed 7 km/h. Magnitude of relative velocity of rain with respect to person. So VRP vector is equal to VR vector minus VP vector. So you see the man is walking on the road with 4 km/h. So we can assume the person is going east. So I'm just assuming it. It is not mentioned in the question. I'm assuming. So this is 4 I cap, and the rain is falling vertically. So minus j cap. Okay, with 7. So minus 7 j cap is velocity of rain. Oh, sorry. The velocity of rain is equal to minus 7 j cap, and the velocity of person is 4 I cap. So the magnitude will be square root of 7 square plus 4 square is equal to 49 plus 16. So this is 65, square root of 65. Okay, second option. Okay, done. Now next question. Now next question is, a man wants to cross 600-meter wide river flowing at 8 meter per second. In a shortest time. So we have a direct formula for that. The minimum time to cross a river is equal to width of river by speed of boat with respect to river, and that is given as okay, we can find it. So this is 600 by 8. Man has a speed 6 meter per second. Okay, sorry. River speed is given 8 meter per second, and man speed in still water is 6 meter per second. So velocity of boat with respect to river is given 6 and W is given 600. So this is equal to 100 seconds. What is the path length covered by man in the river? So the concept is, when the time is minimum, the person or the boat will go from point A to point B. It will not go perpendicular to river, it will go at angle. Okay, so minimum time. So actually this boat is going in this direction. Clear? So this is the distance covered, and this will be the drift. Drift along river is equal to velocity of river into time, which is 100 seconds. So river velocity is given 8, time is given 100. So drift is 800 meter, and the width of river is 600 meter. So we can use Pythagoras theorem. So distance is equal to square root of 600 square plus 800 square. So if we solve this, we'll get 100 square common, 6 square plus 8 square. So this will be 100 square root of 100. So that is equal to 1000 meter. So distance covered is equal to 1000 meter means 1 kilometer. So second option. Okay, done. Now next question. Now look at this seventh question. A man want to cross river of width 500 meter in minimum distance. So if you remember the first question, we have first or second question, we have derived one formula. Time to cross in minimum distance is equal to W by square root of VBR square minus VR square. Clear? So this W is given 500 meter. So we have to find answer in minutes. So let's find answer in hour first. So convert this in kilometer. So this will be 0.5 kilometer. And what is this value? This value is square root of VBR square minus VR square. Now velocity of boat in still water or VBR is given the rowing speed of man relative to water. So still water. So this is still water speed. Still water speed, that is 3 kilometer per hour. 3 square minus VR. The river flow is 2. Okay, so 2 kilometer per hour. So square root of 9 minus 4. So this is root 5. Now this is kilometer per hour. So this is 0.5 hour divided by root 5. Okay, so convert in minutes. So 0.5 into 60 minute divided by root 5. So 30 by root 5 minute. Okay, so now you convert this in 30 is a 6 into 5. So this is a 6 root 5 minute. Okay, so fourth option. Okay, done. Now next question. Now eighth question. Speed of water in a river is 4 kilometer per hour. Speed of water. So that is velocity of a river is 4 kilometer per hour. Man can swim at 5 kilometer per hour in still water. It is missing in question. You write down it is still water. So this is VBR, boat with respect to river. Boat, velocity of boat with respect to river is 5. Minimum time. So T minimum, direct formula, W by VBR. Minimum time to cross by man to cross the river of width 200 meter. So width, now convert this width in kilometer. So this will be 0.2 kilometer and VBR is 5 kilometer per hour. So kilometer cancel, hour, so 0.04 hour. 0.04 hour, or we can say 4 by 100 hour. So this is 1 by 25 hour. Okay, done. 1 by 25 hour, done. Now next question. Now look at ninth question. Speed of boat in still water is half of velocity of flow of water. So still water speed means VBR. Still water speed of boat is given 1 by 2 times velocity of water, river. So this is VR. At what angle boat should steer with direction of flow of water? So suppose this is the river, so that drift is minimum. Drift is minimum means distance is also minimum. Distance is minimum. So the boat should point such that it will go perpendicular to river. So we have this angle alpha. So the components, this is VPR cos alpha, perpendicular to river is VBR sin alpha, and river velocity is VR. Okay, so the boat is pointing like this, but it is going perpendicular to river. Okay, to have minimum drift. So these components are equal. So these two cancel each other. So VBR cos alpha is equal to VR. Okay, so note down. So cos alpha is equal to VR by VBR. So VR by VBR, we have one information given in the question. So VR by VBR is equal to okay, this question is wrong actually. It should be double here. It's the problem with the question. The speed of boat in still water is double. Correct the question. The speed of boat in still water is double velocity of flow of water. So instead of 1 by 2, it should be 2 here. Okay. So VR by VBR is equal to 1 by 2. So cos alpha is equal to 1 by 2. So alpha is 60 degree. Alpha is 60 degree. So the boat is steered along this direction. So this is upstream direction, and this is downstream direction. So we have to find angle. A boat should steer with direction of flow, means downstream. So with downstream, what is the angle? Okay. So this is 60 degree. So this is 120 degree. Okay. So that is the answer. 120 degree is the answer. Clear? And you notice here, the cos alpha value must be less than 1. Okay. So VR by VBR must be less than 1. So VR must be less than VBR. Okay. Or VBR must be greater than VR. Then only the boat can cross the river. So VBR must be greater. Okay. So we done. Now question number 9 finished. Now next question. Now look at this 10th question. A man can row a boat with 8 km/h in still water. So VBR is 8. He is crossing river of width W equal to 8 km, where the speed of water flow, that is VR, is 4. In which direction he had the boat to cross the river in shortest time? So for shortest time, the boat should point perpendicular to river. Boat should point or steer perpendicular to river. So perpendicular to river current. Okay, river boat. So 90 degree with the current. Okay, so done.